Okay, I have a student who hasn't shown up and is running late, so I have a little bit of a time pocket here to do this real fast. If they show up, I will have to suddenly cut this off, so don't be surprised if that happens. We're graphing log functions, so the first thing we need to do is talk about how to graph log functions. Loosely speaking, a log function looks like that. To be a little more specific, it's going to pass through the point 0, comma 1. It's going to pass through the point uh, or I'm sorry, this is not 0, 1, it's 1, 0. Let me get it in the right order. This is a log, not an exponential. It is the inverse. Everything's flipped around. So instead of 1b, it's at b1. Instead of -1, comma 1 over b, it's going to be 1 over b, comma -1. And as I was pointing out, this is literally flipped around from what you would expect to see from an exponential, where you would see this exact behavior. And generally speaking, your teacher is usually happy if you give those 3 points and nothing more. Uh, Also of note that the exponential has a horizontal asymptote, and so consequently the logarithm will have a vertical asymptote. So generically speaking, this is just a log function of some kind. Now, if we need to be specific, we need to think about a few other things, and including shifts and stretches. So a couple quick points. If you have horizontal shifts, move the asymptote first, and think of everything in terms of how far off the line. That's generally how I like to approach these. So those are going to be my quickie notes here for the idea that I think you need to follow. Now let's go to the questions that we're going to be addressing today. We've got 3 questions, 3 graphs, and so the domain of log base 3 of x, that is not going to be stretched or shifted or anything weird. It's just an ordinary log graph. But the domain, if you recall what I drew before, looked like this with an asymptote. So the domain is everything to the right of 0. So therefore it is 0 to infinity exclusive. Range is going to be all real numbers. Or if you prefer, you can say it's -infinity to infinity. Uh, as x goes to blank, f of x goes to infinity. Well, that's going to be as x goes to infinity because it's going that way. And to -infinity, that's going to be as x goes to 0, or if you want to be really specific, 0 from the right. I doubt your teacher is going to actually have a plus sign on that 0, but it gets the point across. Now, let's actually graph this. So the base in this case is 3. So that means that we will still go through 0, 1. We will go through b comma 1, and we'll go through 1 over b comma -1, and we will have our asymptote directly on the axis. So from here, we just got to kind of try to create our graph, which is very tricky to do when we have to go that close to 1 or that close to 0. Okay. Honestly, I would have preferred a much more zoomed in graph than the -10 to 10 field. X-intercept. So we have a 0 along the x-axis at 1. And our asymptote is going to be on the y-axis itself. That is x equals 0. So this, again, this is a standard log graph right here. So if you have nothing weird happening, these are the results you should kind of expect. All right, let's take a look at the second one. Now, the second one, we've got this +3 here. That means we got a vertical shift of 3. Otherwise, it's going to work out the same. So our asymptote is still going to be where it was. It's just that our point that we're going to focus on is instead going to be at 3 rather than at 0. Oh, hello, pussycat. So we're going to go to what would have been 0, 1, or 1, 0 rather, and it's now 1 comma 3. We're going to go to what would have been b comma 1, or 1 comma b. I'm saying it all kinds wrong. Yep. We would go over by 1/2 and up by 1 from here. So that's right here. And then we would go down by 1 and over by 1 over our base, which is 1 over 1/2 or 2. So this is going to be an upside down looking graph. That's kind of weird. I'm not used to doing log of a fraction. Very rare that we would do something like this. But now we will just connect up here and create the shape that we have. End up with something like this. So domain is still 0 to infinity. Range is still all real numbers. We will go to positive infinity as x goes to 0. And we will go to negative infinity. This keeps going down, down, down forever, just really slowly. So this will be as x goes to infinity. Because we flipped everything upside down for some reason. X-intercept. So this will be equal to 0. Well, let's figure that out. 0 equals log base 1/2 of x plus 3. So -3 equals log base 1/2 of x. So we'll do 1/2 to the on both sides. 1/2 to the -3rd equals x. And we will conclude that x is equal to 1/8. 1/8, really? Oh, or no, I'm sorry, 1 over. It's equal to 8. Okay, that sounds better. So it's 8 comma 0. And our asymptote hasn't moved. I mean, it's moved up and down by 3, but it hasn't actually gone anywhere. All right. Finally, we've got this right here, and that is a shift. This is like saying x minus -5. So it means we are going to the left by 5. So this time we do have to move our asymptote. Instead of being on 0, it's on -5. And now from here, we will draw a fairly standard looking log graph. So from what would have been 0, 0, we go 2, 0, 1. From what would have been 1, 0, I keep saying it backwards. What would have been 4 comma 1 would have been 1, 2, 3 here. 1/4 comma 1 would have been here. And so now we connect up. And domain is now from -5 to infinity because we moved it over. Range is still all real numbers. As x goes to what we go to infinity, that would be to infinity. As x goes to the asymptote, we go to negative infinity. X-intercept is going to be at -4, 0. And the asymptote is x equals -5. All right, so I feel like this maybe didn't highlight exactly what's happening very clearly. So let me do one more that's a little more challenging and that looks a little more, it looks easier to address because the graph isn't so darn zoomed in. So let me create a graph here. So let's say that's our main axis, and then I'll create grid lines in this light blue color here. And we are going to consider what's going to happen if we have, I don't want to get too exotic here. So let's suppose we have y equals the log of, which sounds good. What sounds good? Let's go with y equals log base 3 of x minus 2 plus 1. All right, so think about this. We got a -2 on the inside. That means we're moving to the right by 2. We got a +1 on the outside. That means we're moving up by 1. So our origin, if you will, is basically right here. Over by 2, up by 1. That's kind of the point we're going to center everything around. Now, we need to draw our new asymptote, which goes right through that spot. And then our first point goes to the right by 1. So we go to the right by 1. We go up 1 and over by b. and then we'll go down 1 and over by 1 over b. So up by 1 over by our base of 3, and over 1, or down 1 and over by 1/3. And this will create the shape of our graph. And if we have to fill in that other info, we would say that this is going to have a domain from 2 to infinity. It will have a range of all real numbers. It will have an x-intercept at, so we would have a y value of 0 at that 1/3. We don't have to do any solving to figure that one out. What were the other things we needed from that worksheet? We pop back here. Oh, and the end behavior stuff in the asymptote. Okay. So the asymptote, the vertical asymptote, I can spell, I swear, is x equals 2. As x goes to infinity, f of x goes to infinity. As x goes to 2 from the right, f of x goes to negative infinity. So that is a highlight on how these go when there is no stretching involved. Now, when there's stretching or flips, we have to be a little more careful. And we did kind of have a pseudo flip with that second question on the past worksheet here, but this is what you're going to need to watch out for when you deal with these. Hope that helps.